this time I'm actually going to apply that weird rule that we had. Well, it's not weird, I love it, but it could seem weird to people who've never seen it before. So that rule was A upon B equaled AB, C upon D. If that was true, then you could rearrange it and go AD equals BC. This is what I would call a trick, but you can use that trick if you understand that trick. And the trick gets rid of the fraction. And getting rid of the fraction makes our life easier. So what I'm going to do here is I'm going to put those brackets in because they exist. They're just invisible. This line here indicates those brackets are there, but are not written there. So I can take this 5 and I'm actually popping it here. I'm going 5, 3n plus 1 equals, and then I'm looking at these two, 2n. Because I've gone these two, AD, equals these two multiplied together, BC. Okay, so that's my trick. What's really happened, if you want a proof, is I've actually timed both sides by 10, and 10 divided by 5 is 2, and 10 divided by 2 is 5. So I've actually done the same thing to both sides. Okay? Now, here, I can expand. So 5 3s are 15, n plus 5 equals 2n. Okay, so we did that earlier this year when you times the 5. Remember, there's a times sign there. That way and that way. Now we want to get the n terms on the left-hand side and the numbers on the right. So we go 15n minus 2n equals negative 5. What happened? The plus 2n on this side became minus 2n on that side, and the plus 5 on this side became minus 5 on that side. Why? Because here I minus 5 off both sides, and this disappeared, and I also minus 2n off both sides, and that's the 2n disappeared. Okay, so you can do it with a proof or you can do it with tricks. It doesn't actually matter. So now what have we got? We've got 15n minus 2n, which is 13n equals negative 5, and then when we get to here, what do? We are having 13 times n, so we go, how do you undo times? Divide, and that's our answer. Okay, so quite a lot of working there. So here are 3 more examples that I'm going to show you the working that you need to show, because if you show the correct working, you get the points. So here I can say x equals 4 times 10 over 5, so x equals 40 over 5, so x equals 8. What did I do? What's my proof? I'm actually timesing both sides by 10, but 10 divided by 10 disappears. So that's why when I've got divide by 10 on this side, I can put it as times by 10 on that side. Okay? This one, what do I do first? Oh, when I get x equals 8, put it back in there. 8 upon 10, is that the same as 4/5? Yeah, it is. Okay? Here, first thing, get rid of the jolly fraction. That's divide by 4, so 3x minus 7 equals, we times 8 by 4. So what's 8 times 4? Thank you. So that's the working you would show. Then you would have 3x equals 32. How do I get the minus 7 to the other side? That's correct. So 3x equals 39. So x equals 13, or 39 divided by 3. So here we have negative 2x plus 3 equals, we've got divide by 3 here, so it becomes times by 3, so 6 3s are 18. Negative 2x equals 18. We've got plus 3 on this side, becomes minus 3 on that side. So negative 2x equals 15. Now, there's a big idea here. We've got negative 2 times x. So it's really important that you realise that the number is negative and the operation is multiplication. There's actually the times sign there. So how do you undo multiplication? You divide. So you go 15 over negative 2. So x equals negative 7.5. Okay? It's the same as negative 15 upon 2. That negative sign can move up or down. Okay? Alrighty? Has anyone tested that those three are correct? Because we could test them by going back to the beginning. I'm going to show you how you would test them with a calculator. So you can go to menu and equation, and you can push solver. So I can put, I'd have to know that there's a bracket around it, negative 2 times x plus 3 divide by 3 equals 6, execute, and I get negative 7.5. Okay, so I can actually check it that way. X is negative 7.5, so I know that one's right. Another way of checking would be, for this one, I could go 3 times 13. So I've got my 13 and I'm putting it in here. Minus 7. Divide by 4 is 8. If you don't have the brackets here, I got the brackets by executing that and then dividing by 4. Then you won't be able to test it correctly. So the brackets are really important. So I've tested all three and they're done.